Hello friends, my name is Kishan and welcome you in this video tutorial. In this video tutorial, we'll talk about the Java locks. Basically, we'll explore java.util.concurrent.locks package, and we'll talk one of the important implementation of lock interface in this video tutorial, and we'll see an example as well. In multi-threaded programs, access to shared variable must be synchronized in order to raise condition. Java synchronized keyword internally uses the intrinsic lock associated with an object to gain exclusive access to the object's member fields, right? Instead of using an intrinsic lock via the synchronized keyword, you can also use various locking classes provided by Java Concurrency API to have more fine-grained control over the locking mechanism. In this video tutorial, we'll learn how to use these locking classes provided by Java to synchronize access to shared variable. So let's go through the slide. So here you can see one of the class is called Re-entrant and this is the one of the implementation of lock interface which belongs to the java.util.locks package. So when we talk about the Reentrant lock is a mutually exclusive lock with the same behavior as the intrinsic or implicit lock which is accessed via synchronized keyword, right? Reentrant lock, as the name suggests, possesses reentrant characteristics. That means a thread that currently owns the lock can acquire it more than once without any problem. So let's explore these things through an example. So here you can see I have created a class, it's called counter. Basically here we are going to implement a counter kind of variable. So here you can see class name is counter, and here I have initialized reentrant lock, and that is assigned to this local variable is called lock. Lock is an interface which is implemented by this class. So of course a reference to this interface we can assign to its implementation class object, right? Now I have initialized this counter with 0. If even though if you do not initialize, this will be initialized automatically with 0 because this is instance variable. Now I have one method is called increment, and there I am getting lock by calling lock interface reference. So in lock interface reference has a lot of API. One of the API is called lock. So basically here we are acquiring the lock, and once you acquire the lock, then we are doing some kind of compound operation, means we are incrementing this counter by 1, and finally in finally block I am releasing the lock. So here the idea is very simple. Any thread calling the increment method will first acquire the lock and then increment the count variable. When it's done incrementing the variable, it can release the lock so that other threads waiting for the lock can acquire it. Also note that I have used a try, catch and finally block, right? In this example, the finally block ensures that lock is released even if some exception occurs, right? So that's what I am releasing this lock in the finally block, right? So this is the basically counter class, and we have another class is called client test, and there you can see I have initialized executor service with null, and here I am initializing executor service by using this utility class is called executors, and here I have called utility method is called new fixed thread pool and has given the size as 2. So executor service will be created a pool with a working thread of size of 2, right? Now here I have created a object of counter. Now I have created 2 tasks using anonymous class, and in these 2 tasks we have a run method, and within the run method I am calling this increment method, which is by nature is a synchronized, but we haven't applied any kind of basically synchronized keyword. We are using a lock interface to basically to get the more control over the lock, right? Now we are calling increment method 1000 times in this loop in first task. In second runnable task, I am calling increment method 2000 times, and these 2 tasks, task 1 and task 2, I have submitted to the executor service by calling the its submit method, right? And after that executor service, I have called a method await termination to this executor service, and here I have a specified time in seconds, 3 seconds. I'm telling to the executor service I have submitted a 2 tasks, please wait 3 seconds to complete these 2 tasks, right? And after that I'm calling this get counter method, which is available in counter interface. So and here basically 2 threads is trying to increment this counter variable, right? There are 2 threads is basically try to increment this counter variable. Let's see what would be the final variable, final value of the counter. And here one thing you should note down, I am shutting down this executor service in the finally block, right? If you do not shut down, then executor service will be keep running, and that is not a good idea, right? So now let's run this application, and cool, now here you can see the value is coming as 3000, and that was the expected value. I hope you understood this example. This is pretty straightforward example. Now if you go to the log interface, let's go to the log interface. Log interface contains there are some more API available in the log interface. So right now we have used log as well as unlock method, right? So if any thread wants to access some critical section of the code, then has to acquire the log by calling this method, and same we release in the finally block by calling unlock. So that we have already seen. But here there are some there are some extra API. So like log interpretability as well as new condition, we'll talk in the separate video tutorial. But we have, you can see try log and try log with here you can specify the time. So let's talk about these 2 methods. When we talk about the try log method tries to acquire the log without pausing the thread. That is, if the thread could not acquire the log because it was held by some other thread, then it returns immediately instead of waiting for the log to be released. Now second method, you have a try log, which takes time in various format. Here you can specify the time, and here time unit gives you opportunity to specify time in microsecond, milliseconds, second, day, hour, etc., right? So time unit is enumeration, and here you can specify the amount of time, right? So basically here try log, you can specify the timeout in the try log method to wait for the log to be available, right? The thread will now pause for once. Suppose if you specify 1 second time, then the thread will now pause for 1 second and wait for the log to be available. If log could not be acquired within 1 second, then thread returns. So there is very less chance for the deadlock in this situation, and that's what I told you. When you use a log interface, right, then there is very less chance for the deadlock, as well as you will have more control over the log. If you use a synchronized keyword, then you don't have more control on the intrinsic log. That's the issue with the synchronized keyword. So that's all I wanted to cover in this video tutorial, guys. So I hope you enjoyed learning this video. This code I am going to push on the GitHub, and GitHub location you may get from the video description, guys. So big thank you for watching this video.